Bump, 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 ba-dum, bump, bump, ba-da-bum. Math with Learnshare.
Hey,
How's it going,
good
dude?
morning. Oh, excellent. I was able to wake up a good hour and a half before you did. So,
You know,
uh,
that's all that counts really is if you can beat me at waking up, because I'll tell you what. But I did travel 2 hours with this weird what do you call it? Daylight savings time really threw me off a bit. But we've been meaning to make
you
this
want to
video
know
for
what
a
I
lot
call it?
longer than just an hour or two. It's actually been like months that we've been supposed to do this. So I'm glad that it all synchronized. I'm actually kind of excited to talk about all this stuff.
Excellent timing is all I can say.
So this is our buddy, Learnshare. Learnshare, do you want to introduce a bit about yourself? Where are you at right now?
Oh, yeah. At the moment, I'm. Okay, I was making sure I wasn't rehearsing. uh, right now, I'm on the Gulf Coast in Florida. And in the woods. I live way out in the woods, and we have neighbors that we can hear sometimes, but it's generally like when gunfire or something you'll hear, or if they're doing some working, you might hear a chainsaw, or something. But our neighborhood is uh, private. In other words, when you leave the road, you're on our property. All of us own it together. So we have this community out in the middle of the woods, and we all look out for each other, literally watch each other's property, etc. And it's a good functioning society,
So
and
you
it
have like a
is.
fourth world economy, essentially, somewhere in
Yes,
Florida,
yes.
independent and sovereign. That's a pretty sweet idea. I like it.
It's
So how long have you
yeah.
lived in Florida? Like, how is your family from, like, where's your,
No, no. I was born in Georgia. I moved all around the states, and then I moved out of the states, and then I this opportunity of educational opportunity I was in when I lived on the Shuswap Reservation, um, which since I left, they burnt the only bridge that was going to their land, and you only get there now by invitation across the water, and that's it. And I don't blame them one bit. But we had this learning opportunity. The school was limited to 6 students per teacher, so we could excel at our own pace. And believe it or not, we were encouraged to correct our teachers. So having that learning format, it's not a program like this other crap I'd been, exposed to. I was able to excel, and so I graduated in Canada. Went ahead, I completed all the high school by 9 years old. Then my stepfather's like, well, what do we do with it? He takes me to Elkhead University in Kamloops, and I will never forget. I don't remember what representative it was of the school that met us and was walking around with us. He was like, the first thing, what are we supposed to do with him? And my stepfather said, teach him whatever it is he wants to learn. And he knelt down a little bit and he said, what are you interested? What would you like to learn first? I said, explosives. And well, that flew over like a, you know. Anyway, they limited my access to the, and then after moving back to the States and moving from state to state and seeing the localization process that occurs in the programs, literally that's what they're called, from the same publishers with different localized histories. And, I call foul and then I get treated as blasphemers, it's crazy. So I rebelled, and I would sit there in class and do things in my head, projects in my head, and they tried to label me all kind of crazy stuff back here in this school system in the States. And from there, I went ahead and learned from a young age to work, well, out of necessity. It's another story there. Um, and in this situation where everybody's caught up in stuff that I always question, and they follow, um, and through that I was able to start off a base level in the HVACR company, and
What's
wound up being
HDSDR?
heating, ventilation, air conditioning, and refrigeration.
Aluminum siding, you can't go wrong, you know?
Yeah, well, it was an opportunity for me because my comprehension or working comprehension of geometry, I was able to build duct work, full offset transitions, radius,
How old were you
L90s.
when you started that?
Pardon?
How old were you when you started doing that?
17.
Nice.
Yes. And then when I was 18, I was over on the break table fabricating something, and my boss man and the service technicians of the company and the factory representative even were trying to install what is called an anti-knock relay uh, on a 1/3 horsepower power alternating current um, motor. When it stopped, it would abruptly make this knocking sound. In other words, the motor would attempt to run backwards for a split second the moment that the circuit was broken. Well, anyway, I messed up and laughed, I think, after the third or fourth failed attempt by them. And my boss man turned around and said, "What are you laughing at? You think you can do it?" And I was like, "Yes, sir. Now get your ass over here to do it." So I walked over there and I looked at what was going on, and what they had in there, and the little schematic diagram they had. And so I just snatched the wires loose and went back and put it the way I saw it needed to be. And he turned it off and he turned it on, he turned it off and he turned it on, and he's like, he didn't say a word. He walked into the office, he grabbed a stack of work orders, his tool pouch, his keys to the work truck, pointed at me, looked at the rest of the service technicians and said, "Do what he does." And I was on my way to service to solve problems with these systems, these air conditioning, heating, ventilation, and refrigeration. So it was so fun to be able to allow these things to teach me.
And that was kind of like is that kind of when you felt like you were, really interested in living math, or what kind of got you interested into the formulas and that side of it, the living math part?
Dragonfly, hummingbird,
How that,
bumblebee.
so when you were like
As a
little kids
child,
looking at
yes.
nature.
Yeah, because what I was taught, they were breaking the law. In other words, they were blaspheming against this law that I was taught. So
Free food.
yeah, and then my quests began early because I was full of questions and not buying this what I've been taught, because it is obviously proven by nature to be wrong. It's weighed, measured, and found wanting.
That might be something worth pulling up. Let me try to find a picture of bumblebee wings.
Yes. The geometry, the frequency, etc., and comprehension thereof of what is occurring. It's beautiful.
Screen share with Learnshare. Bumblebee wings. So this is a picture through a scanning electron microscope.
Oh yeah.
Of the actual wing of a bumblebee. And when you look at it, it looks so much more awesome than you even realize. Like it has like kind of dragon-like features and these aerodynamic flume chutes that allow the air to be held like feathers underneath them. And this actually can sense also because they move and they pull. Sort of like a nostril will smell, and also the way an ear will hear. So these wings are so utterly sensitive to, see how tiny anything that gets stuck in them is, like crystalline particles. I mean,
yeah, particulates that we cannot see. In other words, what we call air, we just write it off as a single syllable word, 3 letters, But no, just because you can't see it doesn't mean it's not there. That's all I'm saying. And then through witnessing this through nature, it's helped me break these barriers, separate these different areas of study by different words and phrases that mean different things across different fields.
Here's some of the grooves on a dragonfly wing.
Dragonfly, yes, that was my first step into comprehending the conical form and pattern of strength. Thank you, Buckminster, for helping me learn that at a young age. Buckminster Fuller is
we should talk a little bit about how did you get introduced to Buckminster Fuller, and I'll put some pictures up of him while you.
Well, what's simple to me is that 3. It's 3. Buckminster just demonstrated this physically with architectural design. Any design doesn't matter. When you have 3, you have solidarity. If you have 4, you can wobble because you got the joints there. But the special number 3, and I don't want to say derivatives thereof because I don't like calculus. We went round and round. I've even forgotten the fella's name that truly came up with the calculus that we use today. Because Newton's calculus was all right, but the other fella's name I can't recall. It fit better, so they used it. I mean, that part is funny to me, but it's also why I have a chip on my shoulder. Are you rehearsing, brother? You pulling a Learnshare on me? Yep, you're muted.
Sorry, Gottfried Leibniz, I was saying, probably, right? Gottfried Wilhelm Leibniz. He did
Yes, thank you.
Yeah, he's kind of like the calculus boss with the coolest wig in all of math. I mean, like look at his wig.
But it fit better.
I mean, yeah, his calculus and his wig fit better. It's the whole thing.
It all fit better. Yeah, I mean, just the whole thing. So they had
part,
to go.
And look at that double part where it curls there. I mean, this guy loved math. Clearly, you can really tell. But his thoughts on the von Neumann machine, which were a self-replicating machine, concepts really come. This kind of biological machine idea really comes from von Neumann, and Leibniz was the originator of the calculus that made it possible to refine resolution of non-straight line objects. So if you had circles to fill up a square, how many circles could you get in a square? Leibniz was
Well, I can't help but recognize presentations of much earlier work of the same knowledge, same math, same. It's the same, but not the same as the derivative part is not. The empirical is. I don't know how better to word this yet. In other words, the deviations you can make from derivatives of just not including the zero in your calculations is going to throw you off. And then you have to make this adjustments. But
right. I almost always think in terms of if the number is 22, it has a value of 23. If the number 17, it has a value of 18. If the number is
yes, you always add one. You have to add one because they do not start with zero. That's so simple. But you know, that, I mean, to demonstrate that in due time, we'll get to that part.
And Lenny said, how's it going, Lenny? Learnshare and I say hello.
Hey, bro.
But yeah, we're looking at infinitesimals and also the idea of structure in nature. Something that I think, you know, we could all look at the idea of infinitesimals a little bit closer to see how resolution, if you really get down to it, we're looking at orbitals of cohesion and plasmoidal structures. So one of the examples that comes up, because you brought up Buckminster, I think this is a fun one that we were thinking about, is the Buckminster fullerene, which what happened was they found a carbon net that had 60 sides. And this shape freaked out a lot of scientists because to see this in nature, it was like, whoa, how? This is like cooler than a diamond.
It's too beautiful to be
too
accidental.
Beautiful. Yeah. And
too perfect.
And so what happened was Harold Kroto and Richard Smalley, they had to send in data to somebody who could get an accurate example of what was going on here in nature. I mean, let me look at a Buckminster fullerene SEM picture so you can see. In a Buckminster fullerene in a SEM, in a scanning electron microscope, you can see there's a lot of shapes going on, but sometimes you get platelets. Sometimes you get kind of spheroidal curves, but mostly because of the nugget. What you end up having is, you know, something in between a 60-sided shape or a 6-sided shape. And they didn't understand how this could happen. Finally, though, the guy that they were sending in the SEM picture said, well, I could explain this to you a number of ways, but frankly, what you have, Richard, is a buckyball. I mean, I'm sorry, you have a soccer ball. And that was
around the world. It's called football.
The football.
But
right.
Here we call it soccer. Yeah. A soccer ball.
But we can call it the bucky. We should call it the buckyball from now on.
I do.
So that they decided to name it the Buckminster fullerene because Buckminster had designed all these interesting shapes, and he'd figured out, you know, entropy, and said that, you know, one person every generation, if it's 10 people made inventions every generation, then the rest of the world wouldn't have to work. You know, like we just really advanced the world, we could just do it. And he had a lot of really important ideas that led to, you know, first geodesic domes and ultra large versions of these, but then eventually being discovered in nature being using these shapes. So they thought, well, okay, since he was so adamant about the shape, we should name the natural occurring shape after him. So that's a pretty cool thing about Buckminster. But also, you know, in general, one of the reasons why we look at math, because wouldn't it be cool to discover something that's been unnoticed? And there's so many things like that where there's a pattern.
Definitely. And once you comprehend what this pattern is telling you, um, structurally, how they conjugate, come together. And this, I call this fractal conjugation, similar to, well, things that just fit, and it's evidently designed to fit, and it brings in this important question, which is, what is my individual volition when I go from here? Like, if I continue comprehending and gaining knowledge in a certain area to where it could help / harm, what do I do with this information? So that was a question that led me on this quest. And timing, when, and with whom, do I share this information with? Most people already know this information, they just don't know that they know. When you see a shape, if you've been brainwashed by propaganda and misuse of values of certain shapes and numbers, when you look at it, it will affect you in a way that is not pleasant. But if you see things for what they are, instead of this successful programming that's has you predisposed to have a knee-jerk reaction, and I would calling this irrational fear, but it's not irrational if the one that is in fear does not have an access to the knowledge of the truth that would bring the calm necessary to deal with their individual situation. The difference between just you and I speaking, and then you and I speaking and having people listen in, it's like, okay, I need to flow in the correct direction. So comprehending flow, what people would call wave, a lot of times, but it's still flow. There's always flow. There's always motion. There's always current. There's always this presence, this energy. And there was a couple of fellows that got paid to sign their name on a book that proves that it doesn't exist. That what doesn't exist? I'm talking about the air, what everybody just calls air. It's not just air. If we could see more than 0.00000% of what is, then people would it would be a shock for people to see the different like, you can add dye to water, and before a type that's like oil somewhat, but doesn't separate easily or quickly. Well, in air, you do the same thing, like with you take a smoke bomb, and then you can literally watch the air flow if you have built see-through ducting. And this is aqueducts, air ducts, whatever, it doesn't matter. But you get to see the actual forms that occur. And it's beautiful. It's amazing. And it's natural.
And Mountain Cat just asked, was Buckminster a Satanist? And I noticed that if you go to the Church of Satan site and look into it, you can find a number of things about Buckminster, including his interests in LaVeyan Satanism. But I don't think was that his only. I'm not sure if he was a LaVeyan till his death or if it was just early on. But that's kind of an interesting thing. What do you think that gets into? Is there some kind of a connection between
Volition. Individual. In other words, what you know and what you do. Actions and knowledge are weighed. This is just my gut feeling. I don't know why or what, but it just rings true to me that, let's see, how do there's so many times I've seen this occur, and I question everything anyway. It doesn't matter. But it seems like even Edgar Casey attempted to utilize his talents or gifts, or however you want to word this, for personal gain, and then suffered. And then later on, the ability to help came back. I don't know how to word this though yet. I'm working on it. I think it's what we call reciprocity, karma, golden rule, etc., depending on where you're located and how you talk.
Well, also the idea of the architecture of the world being created by Clue or Lucifer, some sort of a architecture system had to be put in place, and it's a perfect mathematical pattern. And this maybe makes sense why base 6 is. I mean, all math is beautiful, but base 6 is kind of interesting. It's something that is its own kind of. It's really unique in and of
Base
itself.
6 is 5 by 5. It's a joke of mine.
Pretty
In other
cool.
words, well, yeah, I love playing and learning. To me, this is fun to play and learn. Speaking of which, in just a moment, I would like to pull up something that I was playing with and learned, and now I can share this, instead of just eluding to there being a whole bunch more order than chaos.
Yeah, K order, absolutely.
Yeah.
Yeah.
So, if you don't mind, I need to take a
Yeah.
restroom break.
Go right ahead. While you do that, I'll talk a little bit about base encoding tables, and then when you get back, if you have any thoughts on base encoding tables, that'll be where we can pick up from.
Excellent. Because you always be my friend. You know too much.
That
I
tends
love
to
you,
be our
brother. I'll be back.
See you in a second. Okay, so looking at how character math is assigned, if you think of it kind of the way sequences happen in octaves, for instance, in base 8, you'd have an octave from 0 to 8 instead of into 10. And so computers work in 10s, but a lot of computers work in 4s, or especially computers work in 2s, base 2 maths. But if you really start to break down GPUs, there's even base 64 index tables, and every kind of math exists. And from that, we get different sorts of subtleties to the mathematical pattern. It makes it much easier to look at, for instance, pi. If you do base 4 math, you can look at pi as a straight 4. And these are the kinds of ideas that have led to Fibonacci and coding and everything that makes computers run today. They can set up a system where you pipe in from one machine one calculator, let's say, in the old days you had an array of an old, let's say like a relay computer. Yeah. Let's say, so here's a relay computer, right? And maybe even looking at something even older would be a better example. Like when you have wires like this connecting a computer, what you can set up is a system where, how about like old computer, 1940s, They don't let me use DuckDuckGo very much anymore. Treating me terribly. Or even a Cray would be a good example. But with these machines, each one of these pieces inside of the machine, each one of these boards, had a specific calculation that it could perform. So it would do adding 10 or multiplying by 10 or computing the logarithm, etc. And then you would take a cable and you'd plug it from one formula relay into another formula relay. So you say, take all the data that is about population, and we've got a machine that's calculating the population. So this is how many people we are. So we've done the central tabulating company, and this is what IBM eventually purchased. So CTC would take data on census, and then they would, in punch card tabulating machines, put this information together. Then they'd have these relay vacuum tube systems, and they'd be able to plug in a tube from one to the other and say, okay, if we took all of the population at its particular growth, and then we added to it this program, and this program would be a code weaving program that takes the numbers and says, what if we have, a population decrease because of a famine? And we start adding the calculations of storms, and then we start adding, and this is exactly what Egyptians do with algebra to figure out how much flooding would happen in the Nile. So each one of these computers would plug into each other, and then we would have a formula of formulas. And this linear computing system of order of operations eventually became what computers are today. And he's back. Can't hear you.
Ta-da! That's awesome.
Yeah, I was talking about how plugging in machines to make one calculator calculate some addition to piping calculations, which eventually piping calculations became piping calculated terms and flexible floating operation points, flops. And so when flops happen, then we'd have more and more flops, and you'd have more and more questions of floating operation points. And you could say, is this blue? Is this red? Is this green? You have one machine that's taking all of the data there and making it just into a pixel. So you could draw a picture, whether it was black or whether it was white, and eventually colors, and then bitmaps. But vector lines and all of these calculations started to emerge, and you could tie together what one number became into what another number became, because you didn't have to worry about the plasticity of the number, because you have floating operational points. So as long as you piped it in correctly from one and it ran, piped into the other, you could have a system that could say, okay, how many of the words that we have in this system are actually words in the dictionary? And are they correct words? And which words are not? And should we add them to the dictionary with definitions, or should we correct them to the most similar word? And which word is the most similar? I mean, this is the beginnings of how computers went from census tabulation machines, and using math became programs for computers. Oh, and look, this is where we're getting back to already.
Yep, right here. This is so simple. You already know this, you just don't know it. I will look at this. Can you see my cursor on one?
No, I can't. Yeah, no, yes, I can see it up at the top left.
Okay. Well, this is your calculator. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? That's 1 through 9. Now, what occurs in this 10-based math system is the relationships between the these numbers show themselves. This is just what you'll see, and I call this the modality of threes. But I don't know what to call it yet. But as a musician, songwriter, and et cetera, et cetera, et cetera, this is how I view it. The 1, the 4, and the 7 are showing their relationships to 3, because if you add these up, it equals to 12. And then 1 plus 2 is 3. Same with these are showing their direct relationship with 6. Notice these have curves in them. Well, anyway, notice these are lines. Okay. If you add the 8, 5, and 2, or 2, 5, and 8 together, you come up with 15. And 1 plus 5 equals 6. And then the same with this one. These are all on the same, I call circuit. And you add these up, you get 18, which 1 plus 8 equals 9. And this shows you the relationships with all these numbers. If you add this up horizontally, this equals 15. 1 plus 6 equals, 1 plus 5 equals 6. Excuse me. So 6s are shown on the corners. Same way going this way. And then if you move this over 1, what occurs? Well, you move the 1 over 1, this is what occurs. And you slide the 9 up to where the 1 was. Then this relationship is remaining constant, doesn't matter. This 1, this 4, and this 7, and this 2, and this 5, and this 8. So as this goes incrementally around, this one, it still has the same property. It still shows us the same information. Wherever we put this 1, wherever we begin, it does not matter. It shows this relationship all the way down. Oh, I needed to hit that. Okay. But anyway, this is so simple. Why is it not taught in school?
Right, and the ideas behind this, if you're familiar with how math is taught in school, it should open up the door. Earlier, someone was mentioning how computers are in binary, and that there are base 10 systems for Egyptian math. But why are we not talking about more base 8, base 6, base 4? Especially in music, you'd think people would be thinking more about base 8 and what's going on. Why are they
12.
hiding it?
We have 12 tones. There's no need
Right.
to divide this crap. Let it be, the truth be known.
Right,
That
yeah.
each tone, there's 12 on that we utilize and have. It's 12 tones.
That's even better, actually. Interesting, because using the 12 system, then you can use the Euclidean harmonies immediately.
Let's see. Okay, we can leap right to that, as a matter of fact. Let's see.
I mean, this will make you a better pop star. Like, for instance,
Yes,
I don't know how
it'll
to
make
sell
you better anything when you have a working comprehension of this. Then that leads me to bring up, let's see, because what you speak of, you're right, you're correct. Plus. Okay, let's get, where is, here we go. All right. It takes a moment for me to get this stuff correct. Okay. Application. I think this was it. Okay. That's too small.
maybe you can zoom in a bit.
Sure. Wait a minute. It is zoomed in here. That might be the problem. Okay. Now let's try this.
Look at the work
Is
that
this
went
showing
into
up?
making these relay computer systems. My God, I mean, just connecting them to each other is so crazy.
This is fun. I'm learning because I have so much to learn. Are you able to see this where it says
No,
Fibonacci Learnshare?
it's not showing
Okay.
up yet.
Let me try
Mountain
this.
Cat says that numbers still make them glaze over, and so that's what I mean when we say like look at numbers more like sequences of patterns, and it might help like looking at let's see here. You see this. Does this look more interesting to you than numbers? Because I'll tell you what, it's a kind of number. And if it doesn't, then how about like notes?
Are you seeing this? Do I have the screen share now
Oh, there it
properly?
is. Now it's showing.
Oh,
Perfect.
okay. We have Fibonacci, which if anyone has taken it down to base form, they comprehend that it has a 24 cycle before it returns again. All right. Now, I call this day and night because it's divided into 12 of equal opposites. In other words, if you take, when I say reduce it to the base number, 1 plus 3 is 4, 2 plus 3 is 1. And through all of this, it shows you this pattern. Regardless, it doesn't matter how far you go, the pattern repeats itself. Okay? Just for if you take 8, this is the beginning of the second half of the Fibonacci sequence. Okay, and you added over 1 equals 9. The following number is 8. Added over 1 equals 9. The following number is 7. Added over 2 equals 9, etc. All the way down. And then when it gets to 9 on top of 9, well, that's 18. And 1 plus 8 equals 9. So it's very simple when it's presented this way, that Fibonacci goes 12 this way and then 12 that way and then begins again. So I have the reverse over here. And notice there's a space here. Well, that's where the 0 is. Now starting, I will explain the best of my ability of reverse Fibonacci is the reverse of Fibonacci. Instead of adding to the previous numeral, you're adding to the next numeral. The following, not the preceding, but the proceeding. Anyway, so 0 plus the next in would be a 1. Of course, will give you 1. 1 plus the next one, which is 2. 1 plus 2 equals 3. And then 3 and plus 3, which is the next one, equals 6. And then 6 plus 4, which is the next one. See, this is the 4th spot here. And then the 5th, you add 5. And the 6th, you add 6. 7th, you add 7, etc. And this is the sequence it comes out to. Now, in this sequence, there are 2 mirrors. This 1, right here, this 10 in this sequence, this 1 has a mirror. It's going up 6319, down 6319. Now, in between these 9s here in this sequence is another mirror. we have 91361 going up and 9163 going down. And
let me pop in really quickly a thing to show too. So just to give sort of a geometric understanding to people who are looking at it. Imagine instead that we're looking at points, or we're looking at straight lines, we're looking at sides. And the same thing can be said for different designs in origami folds. Every fold is the same shape. Every fold has the same number of sides. Every fold produces a continual pattern, and a crystalline pattern. And this is built upon whichever base of math that this particular sequence is in. Okay, going back to you.
Thank you. Yes, I've played in so many, up to 65 base.
Wow. 65 base origami would probably hurt my brain. I want to try it now.
It won't. See, that's once you comprehend this, the rest of it is no longer an insurmountable.
If you think about it in chemistry and nanotechnology, that's kind of with base 60 C carbon, Buckminster Fullerenes.
There you go.
But I definitely had to use computers to do some of those calculations.
And there's a difference between using a calculator and not being able to work without a calculator.
Right.
So comprehending the measurements and dimensions, and that is a key word. Dimensions.
I feel like that is kind of who I am in a way. I can't, like, if I lived 200, 400, 300 years ago, I would have a friend who was a naval calculator. I think that would be like how I would get by, because I would need somebody who had done logarithmic calculations for launching cannonballs over the ship in the wind at different angles. And had a book on the numbers, or was autistic enough to photographically memorize all of the numbers, so that we could, work with that system. Because often, it's hard to keep. How do you feel? You feel like you keep all of these rhymes, right, in your Learnshare head?
So far, the things that I'm calling BS on, like this. The first thing I think of, I'm a musician, songwriter. I think of music, because other than using arithmetic, music is the best way I can express myself. I'm learning how to do this phonetically. But anyway, this crime that has been committed upon us by, well, first of all, changing standard tuning, then later changing the value of a second, which throws off our hertz, because that's a second, all right? The unit of hertz is a unit of measurement to measure frequency. And when they altered the value of a second itself, I mean, if you go back and look what they did, it's like, oh my goodness, man, they just butchered it. I mean, how did they get away with this? Changing to half-life of cesium? What? No. Well, anyway, to try to reclaim these values has been another fun quest, but one I hold dear. And I feel like we're getting close, very close. In other words, if you take a modern oscilloscope that is based on this, what I call bastardized second. But anyway, I mean, this is just my perception, is that once we can reclaim this knowledge and have a practical application thereof to demonstrate, to actually have true experiments with true control, etc., to verify, So that's part of what I'm working on. I'm working on a lot of different things, so I kind of allow them to meld together because in reality they are related directly through the comprehending this information that just shows itself. All you have to do is do it yourself. Like squares. Everyone is familiar with this. This is nature. The different well, let's see. Not that. Let's get
No,
out
that's a
there.
good one. Explain a bit about squares. So, what does it mean to have proportionality in a square, and
Okay.
and delineations?
All right. Let me grab. Basically, what I would say immediately is squares in doubling. In other words, we've taken squares out to 16 and able to see in order to see the rest of the pattern and to comprehend it because it shows itself. In other words, it's self-evident. There we go. Square, square, square. Okay. This is square. Okay, open this one. And then, of course, the following one.
There you go. That's a great visual right there of a square. There's several different versions of squares. There was 9x9s, 8x8s, 10x10s, and you can see
Yes. All right.
the Fibonacci delineating in diagonals.
Exactly. Let's see. Can you see this screen now? Or do I
Absolutely,
need
yeah.
to?
No, it's
Okay, we
perfect.
have. All right. 1, 2x2, 3x3, 4x4, and we've taken these and reduced these down to the single digit. In other words, this is 1, 2, 3, 4, 5, 6, 7. But what occurs with this 5x5 is 6-based math. Okay, that's why I said earlier, 6-based math is 5x5. Anyway, what they we have taken these numbers and gone ahead and stuck with the motif of the 1, 4, 7 being red, and the 2s and 5 and 8s being green, and the 3 is white, the 6 is black, and the 9 is blue. And this is just for visual presentation for us to comprehend the visual manifest that's taking place here. And as you can see, not too much from this pattern because it's only 2x2. But it has so much information when you expand out just that 2x2.
That could be a
Because,
binary hexadecimal.
yeah,
Is you
you
in?
have
Is you in?
3, 4, 5, 6, 7. You see what I'm saying? It's all right there. And then it continues.
And also you have the opposing. Is negatory. Is it an untrue statement values? You can say it from the other direction. Because if it's connected with a 1, that's the 7, because you've got a bit to a byte, and it's eight bits to a byte. So there's usually a secondary system that's referring to the 0 count. And
Yes, because 4 plus 3 plus 1 is 8, and 4 plus 3 plus 2 is 9, and then all of them are 10. So all these numbers are all within this 2x2. But, we can't visually see it until you expand it out and show it, which
some
I'm
people
sure
might
I
not
have.
really find the beauty in this, but this is actually really great because if you can look at the math like visually and you can see it, I mean, this is kind of what Chinese esoterics, the I Ching,
I
gematria,
Ching. Here's your I Ching right here.
right?
This
It's
is I
all
Ching.
this is what it is, and it's in your own tongue. We don't have to go to like other cultures to find how math is its own language. You just go right
Yes.
to it.
And there's different maths, and that's what upset me as a child. Is just like, wait a minute, you're not going to be able to disagree across these. This no, 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 no. You need to get back down to the basics of reality and empirical, um, self-evident truths that prove themselves. Period. And this is part of that. I Ching, you can see the beauty of I Ching. You can also see the 10 base math system here, which is 9 by 9. But this is why using 10 base math system flows this way. Literally, it shows us this. An 11 base math is a 10 by 10 grid, and it seems to mirror. If you take it and turn it 90 degrees, you have this pattern. So the relationships between all of these numbers are so evident once you get out broader and broader, which brings me to here.
Boom.
And we start off with just simple 9 digits. This is nothing but 1 through 9. This is all this is. But what it shows is, let's see, I probably need to increase this a bit. Okay, that should work. We have right here, we have this square, right? I call this tic-tac-toe because that's all you need to do to draw it on paper. And and I learned that translates to butter, cheese, and eggs in Dutch. So how cool is that, man?
That's definitely my favorite part of Tic Tac Toe now. That's the way I'm gonna start talking about it to people. Butter and
But
eggs.
anyway, yeah, these start with 1 in the center, all right, and shows you different relationships. What you will notice is that every other one, all these are 3. Okay, every one of them adds up to 3, which means 12 or 21. You know what I mean? And the same thing occurs with the 2 and its relationship with the 6. Remember, I told you the 147's relationship with 3 always shows itself. And same with 2, 5, and 8's relationship with 6. Those numbers. Well, anyway, 2 shows you this oscillation or phasing in and then phasing out. In, out. Or positive, negative. It's so many things this represents, and it fits that it's too real, too true to be negated. And if there is anywhere that I have made a mistake, I really, 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 really would appreciate it if someone goes ahead and contacts me and said, "Oh, made a mistake here," because that is an opportunity to learn and grow in the moment. So I definitely appreciate critical input. There we go. But once you see this 2 shows you the oscillation of 6 or whatever you want to call it, phasing or whatever. And it does it. It keeps doing it. Doesn't matter. So does this 3. It shows you it's part of this 9 circuit, right? Or its relationship with 9. And then it goes off and then back on. Or in and out, or positive, negative, or positive, negative. I don't know. And it depends on the situation. But these things keep showing themselves. Then we get to the 4 in the center with all things changing all the way around, everywhere, always. And it shows the same relationship with the 3 that the 1 does. It's all these are 3s, then it alternates out or in, or positive or negative, or phasing in and out dimensionally, comprehending dimensions. Um, but it keeps showing itself. It does not matter how far you go with this. It stays true. And part of why I want to share this information is because there's so many people like me, like you, that are seeking truths, but get wound up with dead ends and people that cannot answer. Then there's what's the practical application thereof? Where's the follow up? Where's the completion of this journey? So this 5, it's part of the 258 series or circuit or sequence or pattern. Um, all this is different ways of saying the same thing. This 5 shows its relationship with the number 6. There you have it, in or out, or how vice versa, positive, negative, phasing, oscillation, however you want to word it. It's there. It's equal, opposite, and it's there. Just because we cannot see it because it was not taught to us or presented in this way does not mean that this does not exist, because it clearly does.
What's the USB voltage? 5 volts with 100 ampage, so that it has a 6 volt in its capacitors, using this exact cycle. So, I mean, basically, if you guys use electricity, you're dealing with this pattern in your phone and your USB chargers.
Everything. We're using it right now.
Direct current, and then not even in alternating current, just in direct current. Like this is being used.
Both, all of it. This is
yeah. It's like everywhere.
And there are people that frown or get scared of me. I've been called all kinds of things because I attempted to share in the past information, and I was treated as a crazy weirdo, to blaspheme. How dare you challenge the great works of the giants that came before us, etc. It's like, guys, I'm just me. I'm just attempting to share what I cannot help but recognize. And the solutions they lie within the questions themselves. And like we said to start this broadcast, was I questioned early, so my quests began at an early age.
I was going to say to Brittany, she wants to post these things in the Discord, everybody. I just started a new room in the Exertus Chartery called Mathemagics, and it's tagged in the Speakeasy. I'll send you a send to it, and then we'll start putting math problems and math patterns and geometry, specifically on math, in there, because I think there's a lot of good math that we could be looking at. Lenny, we could also include with that, Lenny and Learnshare. And
of course, the numbers in chemistry have value, even if they're based upon a theory that falls short. It does not matter. The reactions, the interactions, this is all legitimate. Just because things were mistaught does not mean they're wrong. It just means they were not presented correctly, completely, etc. Whether due to limitations of comprehension or something else.
Ahura Mazda says 3 equals magnetism, 6 equals dielectric, and 9 equals electricity.
Hey, now we're getting some relationship comprehensions going on. But there are so many patterns. I'm attempting to. I want to share this with you as well. If this was true 0, it would show zeros down. But this is just to let you know what line we're on as far as number there, and that's all that's for. But anyway, otherwise, this will all be 0. This isn't really a good one to demonstrate it on, except for the yeah, this isn't really a good one. Even though it shows you a lot of good stuff, this one is incomplete. Okay. Where was I at? I've lost my place.
I guess we were talking. I guess if we want to connect the concepts, as we think, relativism of magnetism and dielectric and electricity. Do you want to try to tackle that explanation?
90 degrees. Another reason why this 10 base math flows like it does. Without dielectric and matter, there is no electricity. So, tip hat right there. But at 90 degrees where they meet, it's geometry, but it's numbers. It's still numbers. It's still values. Whether it be range of motion or tipping point of balancing. It's
or also even entropy. I was just thinking, and I would show a real quick. This is a fun one from 3 blue 1 brown, where you have a block that's 1 kilogram and another block that's 10 kilograms, and they're next to each other on a right angle plane, and they have a collision with each other. And when they collide, the energy lost because of the friction, there's a number of collisions that happen. And when you watch them over and over again, eventually they start to count to exactly 3, 1, 4, 1, 5, 9, and you get pi in collisions. So instead of seeing pi as a curve, you imagine pi as a curve in the number of clinks and collisions that interact, and then how fast they interact with each other. So we're able to see pi as an entropical force from a straight flat surface of a flat plane. That's another example where we visualize pi in some sort of an explosion or something. Sorry, Learnshare, are you still there?
Oh yeah, I'm just taking a moment to relieve my bladder again.
But yeah, you can go on. I just wanted to. The increasing collision count also, based on the amount of mass that there is, gives you a more refined value of pi.
Yeah, a lot of people are not aware that collision is what occurs when you have this separation of oxygen and hydrogen for the potential to actually have water fuel for your internal combustion engine. But that's part of so much that is about to just flood everywhere. It's just like today, this, what is it, frontline medical practitioners stood up and said, listen, there is a cure for this COVID finger. And they come out and called out Dr. Fauci, right? And who and all that today, live. And it was beautiful to see that some people that aren't afraid to rock the boat for the better of all of us stand up together. And, I believe that's part of what should occur with everything when it comes to truth.
Absolutely. How are you feeling, by the way? We're about an hour in. Is there another series of numbers or a way of math that we should probably like go over? What's a good?
Yeah, actually, the doubling sequence.
Hmm.
The okay, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, etc. That's where we got this 1024th Native American senator. The math came from because of the doubling sequence.
Moore's law.
Hey, that's a gentleman by the name of Walter Russell. I appreciate his works as well, and other people's works that have helped what I call somewhat break the ice on these subjects to be able to speak about them.
Absolutely. Walter Russell.
Oh yeah, somebody everybody needs to check on.
Your body is merely a machine made to express the thoughts that flow through you and nothing more. It is but an instrument for you to express your imaginings, just as a piano is an instrument for musicians to express his imaginings, just as the piano is not the musician, so likewise your body is not you. Legit.
Yeah,
This guy's cool.
it definitely. When things ring true and what we call resonate with you, there's a reason for that.
The New Thought movement.
Let's see. Okay, yeah, I'm making my way back here. You can tell I'm totally off the cuff. Not really. Well, I'm just me. Nothing special here. But you need to get out of my seat, Gremlin. Thank you. Okay. All right. Yeah, there's so many things here. All right. Like the what is it? Squaring phi to pi.
Anything
Squaring
with
a
fire would be kind of
circle,
fun. Talk a bit about.
and well, there's just these so-called new ways of looking at things or whatever. It's like this is nothing new. All of the so-called Pythagorean triplets are so old. Let me find them. Let's see. I may have shared this with you. I may not. I don't know. But
It's fun to squarify. You can do it with a tuna can.
Let's see. Where did it go? Oh yeah, I got it. Oh, one of our favorite subjects I just went by. Okay. I say that because we had a discussion on tardigrades that lasted about 6 hours, I believe.
Tardigrades are rad.
Awesome. Okay, let's see. And this I will attempt to share. I want to share that. Okay. What we have here. Oh, can you see this, brother?
Yep, just opened it.
Awesome. Okay. This is all the part of the Plimpton tablets that have etched in them. And what is this? Cuneiform? Anyway, it doesn't matter. The Pythagorean triplets are already known and recorded literally etched into stone way before Pythagoras. How do I put this? This knowledge we have lost, and it's up to us to recover, reclaim, etc. For those of us that have the aptitude and talents to do so. Once you recognize it, do you accept it willingly? Well, I do. And, just to help wipe the slate clean from all the crud, which is necessary to be able to process the reality of, whoa. Hey, are you okay? What's wrong with you? I've these feral type cats up in the woods, and they come inside at times.
Sassy cats.
They are not your normal cats. So I'll deal with this and get right back to you. But anyway, yeah, the Plimpton tablets definitely worth looking into if you're interested in evidence of this knowledge from before time.
Maybe we should zoom in on this when you got a second to look a little closer.
Okay. Yeah, I just had to step out and put the
No worries, man. I feel like everyone
little
has to
monster out.
apologize to their cats. They're like, no, my cats are like not like no other cats. I don't want to be like prejudiced against cats or nothing, man. Cats are pathological liars that kill mice and leave them in your doorstep and make you punch.
Cats are jerks. Mine are anyway. As you can tell, there's little information missing from these tablets.
Interesting. Why is it scrubbed? What the censorship? Look at that. It's like a bikini. A bikini on E in the 90s on TV.
Are you familiar with Mayan calculator?
Totally. The 5 points.
Oh,
and
okay.
the 1 line. Yeah, I love the
Yes,
Mayans.
yes. Okay. Well, this will help you with reading this.
Similar like notches and lines for 5 and 1s. Is it in 5 systems? Mayan numbers have like hieroglyphic values of 13, 20, 5, and 1, which can be used in different systems. The 13, and each one counts 0, which is great.
Yeah. 137.5 degrees. All these numbers and that have values, individual values, and relationships with others that really, once you really want to have a working model of something utilizing this, you already do. It just isn't using it as good as it could be. I've literally walked through manufacturing plant with a factory representative bragging to me about them firing all of their designing engineers and hiring all new ones using new formulas. And I looked at these formulas and I'm like, wait a minute. You rounded up in your formulas. A little smile. And I'm like, okay. And so it's obviously they want it to last about as long as that warranty does. And that's it. So I was like, dang, man. If people, and as we the people had the knowledge of how things work we would be way less dependent and more independent. But different number systems. Before we go, I don't know how much time or how long you were wanting the show to be. So that's
Yeah, we could do another 10 minutes or so. I wanted to really quickly also show an example being on
oh yeah. How about
Arabic have these
I have an
degrees like we
idea.
talked about. Here's a
Um
72 degrees on a decagram. And
oh
we
yeah.
looked at
You have
the
720, 180,
20 degrees.
360, 1080. I mean, most people are already aware of this. This is your pixel count or whatever. This is your frame rate. This is your definition of your television. This is like 720p or 480p, 720p, 1080p, 1440p. This is the same math. It's that we already use. And we already know this, but we don't know that we know this because it hasn't been presented to us. Now, I would like to open up a song. Let's see. This is using one of the number sequences. I imagine I need to pause this for a moment and go back to the share thing.
Open up your screen share, and I'll put my thing on. I just put on the, or I'll turn off mine and put yours on. I was just looking up also vertex arrangement of polytropes is really an interesting concept when you think about how
Yes.
these are the wings of the dragonfly that we're talking about. Some of this stuff, depending on if they're rhombic or if they're sexagesimal or quadrilateral. I mean, the convex hole polytropes are the ones in nanotext that have curvature, which is really interesting in Euclidean space.
Yep.
And non-Euclidean space is even cooler. I grew up in non-Euclidean space. I had to walk uphill both ways.
Cool.
I thought that was a good math joke.
Excellent. Maybe. Okay, yeah. That's awesome. I forgot what I was about to do.
Oh no!
No, I remember now. Share audio. Oh, this is a friend of mine. I call her sister when I address her, and her husband as my bro. But she took these numbers.
Oh, your screen share closed. Do you?
Oh. Okay. What about the sound here? Is that audible?
No.
Okay. I have to do this again. Share.
The Cauchy-Schwarz inequality.
What are we seeing now? Can you see this?
Yeah.
List?
I see it now.
Okay. Anyway, she called it learn numbers, but it's a pattern of numbers I gave, or actually she recognized. She said, "I see music." I said, "You sure do." And then, well, anyway, this is what she sent me: a practical application of that sequence in music, and I'll just let it speak for itself. It's simple, one little pattern. So this is meant to be one little sequence of a song. But she just played with it and showed me what it could be. Here we go. You hear this?
No. Put your microphone to the speaker, maybe.
Oh, no. Really?
Yeah, it doesn't pipe it through the software. Unless you have sound flower.
No. Okay. Well, I don't know of another way to do it yet.
Oh, send me the link and I can play it, I guess. In the private chat right there. Do you see on the
Okay,
right?
okay.
Send me a link and I'll open it up. In the meantime, I will talk a little bit about Viktor Bunyakovsky, who was a St. Petersburg mathematician. St. Petersburg is a more Tartar and Rus and German place. But I think he was born in the Ukraine. Yeah. And he's a Tartary scientist who was brought from Bar. Yeah, from Bar. Yeah, and so Bar is a Polish kind of city in the Ukraine. That is this. We talked earlier about their systems of government, and you'll notice they have the Apollo sun god and the key and these very Tartarian style. This building is very specifically does not look like a Russian church per se. So the mathematician who worked on different kinds of vectors figured out propagation of heat to the solids. This is kind of the most useful part of solid state kinetic physics. And it eventually worked into electrical physics, but also into thermodynamics. It's used in almost every sort of nuclear or volcano energy system. It's a number probability theory that has to do with entropy and thermodynamics. Are you Learnshare, did you get that file sent to?
Yeah, send it a DM and this.
In Discord? Okay.
Yeah.
I don't see it. I don't see it yet.
It's processing.
Oh,
There you go.
there it is. There it is. Okay. All right. I'll try this, guys. Pretty legit.
Oh yeah, and now that's just one part of a song. So can only imagine what the rest of it is going to be like.
Well, that's pretty good, man. I'm glad that we did an episode on math. I think we should do more kinds of things like this. Maybe if we had like a mathematical objective to visualize. I know some people don't really get the value of this abstract magic stuff, but it's you know, it's okay if you don't
It's
love it.
okay.
If you don't love it, that's fine. And I think for the
Yeah.
most part, the people that did get through this, I hope that you did understand a bit about how to visualize math in the physical real world and the way that it's made things possible like dragonflies, because that is really worth understanding. It's a beautiful thing.
Beautiful. It's natural. Its design is immaculate, divine, lovely. I mean, I'm in constant awe. Uh, Once you begin recognizing these things, you hmm, appreciate things more.
Math
You
is hot.
can. Oh man, it's part of me, you know. I cannot change, but I can continue to learn and share, which is what I intend to do.
And also in terms of straight lines, non-straight lines, Euclidean vectors, non-Euclidean vectors, the concept of curvature in an infinite space, which actually makes sense in a nanoscale, believe it or not. So to describe aerogels and plasmoids.
Oh
And
yeah,
this is
a lot
all
of
how motors work inside of your body to make ATPs to make all your
correct,
biology. And
correct.
it's amazing.
Yeah, without this motion, there would be nothing. Literally. And torque is the leader. Angular momentum is always going to follow torque. That's the speed of rotation or spin. Um, uh, if you have like a little top, or you can spin a coin as long as it maintains this angular and this speed, this rate of speed, it will stay perpendicular or 90 degrees to the plane. Um, but yeah, it's very simple, but it could be so confusing to a lot of people because they had been taught differently.
I think this has been pretty awesome. I hope that we get people to check out the Mathematics channel on the Discord, and let's start posting some stuff there on ways that they can look at base math. And maybe some of you guys will win at Keno or something on the internet. Who knows? So use your math.
Not to mention, lots to learn, and those of you out there that are not afraid to share information with me, I would very much appreciate it as
Right.
I'm learning.
Yeah. Anybody who has any information, there's always more to share at the Discord. All right. Thanks a lot, man. Learnshare.
Hey, thank you, brother. It's about time. Like I said, it was time.
Yeah. Hope we do these
Excellent.
again soon.